Hello everyone, this is Mr. Mullen for lesson 8-5, using intercept form. So today we're going to be looking at graphs and we're going to be writing them in intercept form here. So it says kind of here in the directions, we're going to write it as f of x equals x minus p and x minus q, or if it's an upside down graph, it's going to be negative x minus p and x minus q. So kind of important that it says x minus p and x minus q, because some of these might look backwards to you, and it's because the formula starts off as x minus p. And really all we're going to be doing is looking at the intercepts. So we have f of x equals x minus 1 intercept in one parentheses and x minus another intercept in the other parentheses. So if I look here, my intercepts are 1 and 2. So my answer for this is f of x equals x minus 1 and x minus 2. Okay, so same thing here. We have f of x equals x minus 1 of our intercepts and the other intercept. So here, kind of the same thing. Looks like our intercepts are positive 1 and positive 2. And then except since this one is facing down, I should have a negative sign out in front, which kind of just looks like another part of the equal sign. So negative x minus 1 and then x minus 2. All right, if I look at letter C here, so f of x equals, this one's positive because it's going upward. So x minus some number, and then x minus another number, and it looks like here our intercepts are 0 and 1, 2, 3. So x minus 0 and x minus 3. Okay, D, we finally get a negative 1, so we'll see how that changes our answer. Oops. So now that we have a negative intercept, instead of x minus a negative 3, we're going to just change that minus a negative and end up doing a plus 3. So we have x plus 3, and then x minus 0, or really x plus 0, doesn't matter because it's 0. You can't have a negative 0. All right, next one, f of x equals, it's upside down, so I'm going to remember to put the negative out in front this time. And same thing, x minus 1 intercept, x minus the other intercept. And then kind of the same thing as D. It is at negative 3, so minus a negative 3 is really the same thing as plus 3. And same thing, that one's at 0. I'll just put a plus 0 so that they're both the same. And then F, we have f of x negative, and then same thing, x minus, x minus. This time my intercepts are at 0 and 3, so I'll just keep it as 0 and 3. There's 2 more on the next page. So f of x, a good one of each, equals, this one's positive, so going up. So x minus a number, and then x minus a number. This first intercept is negative 1, so minus a negative 1. That minus a negative 1 turns into plus. And this one's at positive 2, so it'll stay at that minus 2. And then letter H here, so f of x equals, since it's upside down, it's going to have that negative there. And then same thing, x minus a number, x minus a number. This time it's a minus a negative 1, so minus a negative 1 turns into plus 1, and then there's the 2. So you're pretty much just saying the intercept. Again, it's kind of backwards of what you think it would be, so just kind of be aware that some things might look a little strange and might look a little backwards to you. Okay, so here on number 1 and 2, they want us to find the x-intercepts and the axis of symmetry. So to find our x-intercepts, we're going to pretty much just set them equal to 0 like we've done a couple times here before. So x plus 2 equals 0, and x minus 4 equals 0. So I'm going to subtract 2, and we figure out one x-intercept is negative 2. This problem, I'm going to add 4. I figure out my other x-intercept is 4. So 2 x-intercepts, one is negative 2, one is positive 4, but it also wants us to find the axis of symmetry. To find the axis of symmetry, we need to find the average of these two numbers. And remember, to find the average, you add them up and divide by 2. So negative 2 plus 4 is 1. So my axis of symmetry for that problem is 1. Okay, number 2, same thing. So x minus 2 equals 0. X minus 3 equals 0. So got to find our intercepts first. So add 2 to each side. So one intercept is 2. Here we add 3 to each side. The other intercept is 3. So one intercept is 2, one intercept of 3. Axis of symmetry is then in between 2 and 3. So 2 plus 3 is 5. 5 divided by 2 is 2.5. All right. If you look here, it says to graph the quadratic function, label the vertex, axis of symmetry, X-intercept, and describe the domain and range. So, whoa, lots to do in these next couple. Okay. So here, since it's x plus 1 and x plus 5, remember this plus means I'm going to move over to the left. So 1, 2, 3, 4, 5. So there's one dot. This plus 1 means I'm going to move over 1. So there's another dot. So let's start writing this out. So my intercepts are at -5 and -1. Okay? So that's checked off. Axis of symmetry is the average of the two, or the middle. So what's exactly in between -1 and -5? Well, my axis of symmetry, that is -3. Or like we did for 1 and 2 up here, we find the average. -5 plus -1 is -6. -6 divided by 2 is -3. So we found that. Okay, vertex, we have not found this yet. So to find the vertex, we know the axis of symmetry is -3. So we need to plug that -3 into my problem. So -3 is my x. So -3 plus 5, that's 2. -3 plus 1, well, that's -2. And 2 times -2 is -4. So my vertex is then at -3, -4. So that's going to be 1, 2, 3, 4 right there. So then this is what my graph would look like. So you need to find the vertex because you need to know how skinny or how fat the graph is, if it's a stretch or a shrink there, because you know the intercepts right away. But we need to find the vertex then to see how far it's going to go down. Okay, domain, just like always, all real numbers. And the range, well, my low point of this graph is -4. So I know y has to be greater than or equal to -4. There's no way this graph is going to dip below -5. The numbers are just going to go up from -4 there. All right, so it's kind of a lot of work for those problems. So let's look at number 4. So same thing. Let's find our intercepts. So I'm doing my graph here. So 3 to the right and 1 to the right. So that means my intercepts are 1 and 3. My axis of symmetry is exactly in the middle between my two intercepts. So right in the middle between 1 and 3 is 2. Or again, if we take the average, 1 plus 3 is 4. 4 divided by 2 is 2. Vertex, we got to do some math here for. So we know that x is 2, but we got to figure out what that y is. So I'm going to plug in 2 for my x. So x minus 3, and it's 2 minus 3, so I get a -1. X minus 1, so positive 1. So I still have this -4 on the outside. So -4 times -1 is positive 4. Positive 4 times 1 is just 4. So that means my axis symmetry, or my vertex is 2, 4. So 1, 2, 3, 4. So as you can tell here, this one's going to be a pretty skinny graph. And that's because of that 4 on the outside. Oop, except it's 2, positive 4. So it's going to be 1, 2, 3, 4 up there. Make sure you pay attention to your signs like I was not. So pretty skinny graph then there because of the stretch of 4. Domain, all real numbers. Range, y has to be this time, since it's going down, has to be less than or equal to 4. This graph will never be at 5 or 6 or 7 or anything like that up there. All right, 5 kind of looks different from 3 and 4, so you just got to factor that out. So x squared minus 4, which is really the same as x plus 2 and x minus 2. So otherwise, just one more step. They're just books seeing if you remember how to factor. So you have x plus 2, x minus 2. So that means my intercepts are 2 and -2. So this one makes me go 2 to the left. This one makes me go 2 to the right. Okay, axis of symmetry. My average of 2 and -2. Well, 2 plus -2 is 0. 0 divided by 2 is 0. So my axis of symmetry is 0. So now I got to plug in 0 into that graph. Okay, so 0 plus 2 is 2. 0 minus 2 is negative 2. 2 times negative 2 is negative 4. So 1, 2, 3, 4. So my graph will look something like this. Domain, all real numbers. And the range, it has to be greater than or equal to 4. There's no way it's going to get any lower than 4. Okay, 6. Now we got to go back and do some thinking, figure out what our parentheses are. So two numbers that multiply to negative 15 and add to 2 is going to be positive 5 and negative 3. Okay, so positive 5 means I'm going to go left 5, so dot there. And negative 3 means I'm going to go right 3, so right there. So that means my intercepts are negative 5 and 3. My x symmetry is what's in the middle there. So negative 5 plus 3 is negative 2. Negative 2 divided by 2 is negative 1. That means we need to find our vertex now. It's going to be negative 1 something. So negative 1 plus 5 is positive 4. Negative 1 minus 3 is negative 4. So 4 times negative 4 is negative 16. So kind of far down here then. So I'm at negative 1. We'll just say negative 16 somewhere down here. It didn't exactly plot it out, but it'll look something like that. Domain, again, all real numbers. And then my range, y has to be greater than or equal to negative 16. The graph's never going to go and dip below that negative 16 mark there. Okay. Here, kind of the same thing. We need to find the zeros. So we just need to find those intercepts, basically. When they say zeros, that's kind of just the same thing as intercepts. So I have a 6 that I can pull out. So then once I factor this, x plus 1, x minus 1, your zeros are negative 1 and positive 1. That'll make your graph equal 0. Same thing here. So two numbers that multiply to 20 and add to 9. So x plus 5, x plus 4. The way to make those zeros is negative 5 plus 5 is 0. And negative 4 plus 4 is 0. And then pretty much the same thing here. We're just trying to find the zeros there and how we're going to graph it. So two numbers that multiply to negative 10. So I have x minus 5 and x plus 2. So that means I just figured out my zeros were positive 5 and negative 2. Okay. That means it moves 2 that way, 5 that way. And it doesn't say to find the axis symmetry or the vertex or anything like that, but we're going to use those zeros to kind of find that. Okay. And then same thing down here, except now we have x to the third. So now I need to pull out an x. If I pull out an x, I'm left with x squared minus 9, and I can factor that out even more. So x plus 3 and x minus 3. So now if I find my zeros, I actually have an extra 0 here. I have a 0 there. X minus 3, so negative 3 is also a 0, because negative 3 plus 3 is 0. And then positive 3 is also a 0. And I have x minus 3 equals 0, so 3 minus 3 equals 0. So now I'm actually going to have a couple here. So that means I'm going to have a dot at negative 3, at 0, at positive 3. So then when you kind of go to graph these, you're going to end up having a funky looking graph that looks like this. So when you see these x to the third things here, like you do for 11 and 12, you're going to end up having a funnier looking graph. Again, nothing's different here. We found the 3 zeros before. You just need to figure out what numbers make the equation equal 0. So just like this, kind of just like number 9. Number 9, we did it for 2 problems. Number 11, we did it for 3 problems. Otherwise, it's going to be pretty much the same thing as the other stuff that we did before.